So now let's talk about remainder and fractional theorem. Sometimes what happens is in questions they are going to give you a very long binomial theorem and they are going to divide it with some number. Then you would have to find out what would be the fractional part of that, or after dividing what would be the remainder after dividing, what are you going to get. So for such questions there is a trick, of course. So let me take an example to help you understand better. Let's say if we have 16 to the power 2025 24 divided by 5. Now I need to find out what would be the fractional part and remainder of this entire function. So what are we going to do? For such type of questions, our first step should be to convert our numerator in such a way such that there is one number which is divisible by 5 and the other number is either 1 or something else. So from here we can see that 16, how can I write it down? I can write it down as 15 plus 1, where 15 is divisible by 5. However, 1 is not, right? So from here, I can write this down as 15 plus 1 whole to the power 2024 upon 5. So this is how I can open this up. Now, if I open this binomial theorem, how is it going to be opened? It would open up as 2024 C0 15 to the power 2024 plus 2024 C1 15 to the power 2023, and this would continue on forever, and we would have 2024 C 2023 15 plus 2024, and in our last term we aren't going to have any 15. It is going to be 15 to the power 0, right? So it is just going to be as it is. This is our expansion and this divided by 5. Now what I'll do is, here you can see that there are a lot of different terms here. In all of my terms, I have a value 15 in it, right? I'm going to have at least 115 there. If I have 115 also, it can be divisible by 5. That term can be divisible by 5. Apart from the one which does not have 15, it cannot be divided. So that would become our fractional part. So if I was to show this to you in a more simplified way, this would become 2024 C0 15 to the power 2024 divided by 5 plus, here I would have 2024 C1 15 to the power 2023 divided by 5 and plus, and this would go on up till we have 2024 C 2023 15 by 5 plus 2024 C 2024 by 5. So this is what we are going to have. Now to find out our factors, or let's say fractional part, what we can do is, we know that this thing is going to be divisible, so we would get an integer value in this. We are going to get an integer value here as well. We are going to get an integer value in all of this. Basically my 5 would get cancelled out with any one of the 15s, right? So I would have an integer value in all these terms. I would have integers in all these terms. However, the last term, this is the only term that is left out, this which is 1 by 5. So this value, the one which is left out, now you must look at the value which is left out. Your denominator should be greater than your numerator, first thing. For such values which are left out, values left out should have denominator greater than numerator. If that is the case, then of course this becomes my fractional part simply. So this is nothing but my fractional part. And if I was to find out my remainder, it would simply become denominator minus numerator. So for this, my remainder would become 5 minus 1, which makes it 4. This is my remainder and this is my fractional part. So this is how you are supposed to solve questions which are related to remainder and fractional theorem. Again, there is no specific formula for you to solve such questions. You must open up your binomial theorem, try to find out values which can be divisible by your denominator, and then solve your question. Let me take one more example to show you. Let's say if you have 4 to the power 2022 upon 50. Now this was a question that was asked in one of the previous year JEE Mains. How are you going to find out the fractional part? Since we have 4 to the power 2022, now I need to make this value in such a way such that in my numerator I have a value which is divisible by 15. So what I can do is, I can write this term as 16 to the power 1011. I've taken 4 squared as common, so it would become 16 to the power 1011. And now this 16, how can this 16 be written down as? It can be written as 15 plus 1 to the power 1011. I hope you are getting it. Now, if I try to open this up using my binomial theorem, I would get 1011 C0 15 to the power 1011, and this would go on forever till we have 1011 C1011, and we would have a 1 here. So of course, if I divide this by 15, all these terms which come before 1011 C1011 are going to come out to be integers. The only term that would be left out would be 1 by 15. So basically, if this is left out, I can see that my denominator is greater than my numerator. So this becomes my fractional part. Very easy question. I hope you must have understood it. Now let's say if instead of fractional part, if the question would have asked you to find out the remainder of this particular question, what would your remainder become? 15 minus 1, which becomes 14. So this is your remainder and your fractional part. Let's look at one more question. Now let's look at a different type of question. This question would be quite lengthy. We have to find out the remainder when 7 to the power 103 is divided by 17. So if you look at the multiples of 17, 17 into 1, what do we get? 17. 17 into 2, what are we going to get? 34. 17 into 3, what are we going to get? 51. Now, if I look at all these three numbers, out of these three, the one which is most close to 7 is going to be 51, because I can have 7 square as 49. So I can write it down as 51 minus 2. I hope you're understanding it. So basically, I need to have such type of value in my binomial expansion, which is less than the one which I'm dividing it by. So basically what I'll do is 7 to the power 103. I can write it down as 7 into 7 to the power 102. And this basically can be written as 7 into 49 to the power 51. And this now can be written as 7 into 51 minus 2 to the power 51. This is how I can write this entire equation. Now I know that 51 is divisible by 17. So I would now try to remove all those terms which would have 51 in them. So I'll start with my binomial expansion. So if I try to expand this, and I'll write down the 17 below directly. So this would become 7 into 51 C0, 51 to the power 51, 2 to the power 0, and below we have a 17, plus 7 into 51 C1, 51 to the power 50. We would have a 2 also multiplied now, plus 17. And this would go on forever till we have 7 into 51 C50, 51 into 2 to the power 50 divided by 17. And our last term would be 7 into 51 C51, 2 to the power 51 upon 70. So in this question, of course, all these terms would give you integer values, because 51 is divisible by 17. So I can take any one of the 51s divided by 17. I would get integer value in all these terms. So the only term that is left out is this one. And what is the value of this term? 7 into 2 to the power 51 upon 17. Now here you can see that I've gotten my numerator to be greater than my denominator. So what am I going to do? I'm going to solve this question again based on the solution that I have. Now I would look at this question. I can see that I should have a value in my numerator which can be somehow divisible by 17. So I'll try to create 16 in my numerator, because of course I know that 16 can be written as 17 minus 1. And of course, if I have 17 minus 1 in my numerator, I can divide it by 17 very easily. So I'll try to convert this into 16. So if I just take the numerator, what do I have? I have 7 into 2 to the power 51 by 17. How can this be written down as? This can be written, I'm just taking the numerator. This can be written as 7 into 2 to the power 3 into 2 to the power 48. Now, why did I take 2 to the power 3 common? So that I can have 2 to the power 48, where 48 is divisible by 4. So that I can write down my 2 as 16 to the power something. So basically, this would become 7 into 2 to the power 3 into 16 to the power 12. This is how I can write this down, right? Now this entire thing can be written as 7 into 2 to the power 3 into 17 minus 1 to the power 12. Now let me open this binomial expansion divided by 17 and let's see what are we getting. So this would basically become 56 into 12C0, 17 to the power 12 upon 17 minus 56 into 12C1, 17 to the power 11, and we have a 1 there. So of course we've taken our minus 1 outside. This would become 17 plus 56 into 12C2, 17 to the power 10 divided by 17, and this would go on up till we have 56 into 12C12, 17 to the power 0, which does not require it to be written down, upon 17. Now, of course, all the terms which are before 12C12, they are going to have at least 117 in them. So all these terms would simply become integers. So what are we going to be left with? We are going to be left with just this, which is nothing but 56 by 17. So now we've shortened down our remainder or our fractional part to this portion, which is 56 by 17. Now I hope you all can see that 56, how can I write it down? I can write it down as 51 plus 5 upon 17, which can be written as 51 by 17 plus 5 by 17. This portion again becomes an integer. And now I've gotten this. Now here, this value, which is my 5 by 17. Here I have my denominator greater than my numerator. So this becomes my fractional part. So this is how you are supposed to solve such questions. Till the time you get your numerator to be greater than your denominator, you are supposed to solve it using either binomial theorem or either factorization or any other method. The moment you get your denominator to be greater than your numerator, you will have that as a fractional part. And now if I was to find out the remainder, it would simply become denominator minus numerator. So 17 minus 5, which makes it 12. This is my answer. So this is how you are supposed to solve questions related to remainder and fractional part theorem. So keep this method in mind. Now let's talk about multinomial theorem. What if inside our bracket we have more than two terms? Then how are we going to open it up? So let's say if we have x1 plus x2 plus up till xk to the power n, how can this be opened up as summation of n factorial upon r1 factorial, r2 factorial up till rk factorial, x1 to the power r1, x2 to the power r2. So basically this is my general term. And one important thing that you must remember for multinomial theorem is that r1 plus r2 plus r3 plus rk up till k should be n. Here, one major thing that you must remember is that k is basically the number of terms inside my bracket. So this is number of terms inside my bracket, or basically number of terms inside my multinomial. So this is one thing that you must remember. Now if I was to look at the explanation of these general term, so I would have n factorial, which is the total number of ways of arranging n items. R1, R2, Rk are the powers assigned to each term, and then this becomes my multinomial coefficient. So how are we going to solve questions? Let's say if you have been given x plus y plus z to the power 3. So here, from here you can see that my n is 3. This power is my n, which is 3, and my k value also comes out to be 3 because there are three terms x, y, and z. Now, from the first thing what I'll do is I'll write down my general term, which becomes 3 factorial upon r1 factorial, r2 factorial, r3 factorial. Of course, I can go up till rk, right? Here my k is 3, so I would have r1, r2, and r3. This would be multiplied by x1 to the power r1, x2 to the power r2, and x3. Sorry, this is my x, this is my y, and I have my third term as z. So this would become z to the power r3. So this is my general term. Now in this general term, one thing that we studied was this r1 plus r2 plus r3 up till rk should be n. So I can have r1 plus r2 plus r3. This should be equal to 3. Now what I'll do is I'll start taking up cases. how can I distribute 3 in these three combinations? So if I try to draw a table R1, R2, R3. So I can have either R1 to be 0, R2 to be 0, R3 can be 3. So their sum would become 3 basically. I can have 0, 3, 0 as one of my combination. 3, 0, 0 can be one of my combinations. 2, 1, 1 can be one of my combinations. 1, 2, 1 can be one of my combinations. And 1, 1, 2 can be one of my combinations. Sorry. This is 1 here. I can have 1, 1, 1 as my one of my combinations, or I can have 2, 1, 0. I can have 1, 2, 0. I can have 0, 2, 1. I can have 0, 1, 2. So all these combinations I can have. So there are basically 4 and 4, 8. So what are the other more possible combinations? I can have 0 in between. So I can have 2 here, 1 here. I can have one more 0 in between, and I can have 1 here, 2 here. So these are the possible combinations of R1, R2, and R3. Now, based on that, I'll simply write down my expansion as 3 factorial. I'll take the first case where I'm taking R1, R2 to be 0, R3 to be 3. Then I'll take the second case, third case, and I'll add them all together. And based on that, this value now becomes my expansion of this simple term. So this is how you're supposed to solve questions of multinomial theorem. So keep this thing in mind. The most important thing is that R1 plus R2 plus R3 up till Rk should be equal to your n. So again, repeating the same things, the general term is written in this format. The total number of terms is going to be n plus k minus 1 cn, which is n plus k minus 1 ck minus 1. I hope you all know this theorem, that NCR is equals to NC n minus r. So basically that is exactly what has been done here. If I put my n as n minus n plus k minus 1, so it would become n plus k minus 1 ck minus 1. So either of these is possible. Now another important property is that the sum of all coefficients is obtained by putting all x's equal to 1, which is k to the power n. Now let's say if in this equation I put x, y, z as 1. So all these values would be gone, and I would be finding out the sum of coefficients, my multinomial coefficients. And I do not need to calculate my sum of my multinomial coefficients. I can directly write it down as k to the power n. So keep this formula in mind as well. Sum of all of my multinomial coefficients come out to be k to the power n. Again, a few more things. So number of terms in this expansion, of course, you can simply use this formula, n plus k minus 1 c n, k minus 1 c n. What is your n here? N is simply n and my k is 3. So if I replace my k as 3, I would get n plus 2 cn, or this can be written as n plus 2 c2. So that is exactly what is here. And this one basically becomes, I can write it down as n plus 2 into n plus 1 upon 2. So of course, this is just the opening of number of terms. So just keep these things in mind. Even if you do not remember this standard format, of course, you just remember this formula, the total number of terms, and based on that, you can calculate your answer. So now let's look at this question. What would be the coefficient of x to the power 7 in this multinomial? So of course, I can see that this is my multinomial. So I'll first write down my general term. In binomial theorem, it is always necessary for you to write down your general term first. So my general term would become 10 factorial upon r1 factorial, r2 factorial, r3 factorial into x1, which is 1 to the power r1 minus x to the power r2 and 2x cube to the power r3. Now, if I try to simplify this, if I try to take all the x powers together so that I can find out what my x to the power 7 is going to be, how can this be written? This would become 10 factorial upon r1 factorial, r2 factorial, r3 factorial. This would remain as it is. 1 to the power r1 can simply be removed. We would have minus 1 to the power r2, and we would have 2 to the power r3. And what would be my x left out, it would become R2 plus 3R3. This is what I'm going to have. Now, in this general term, I need to find out what my coefficient of x to the power 7 is going to be. So that means I need to put this value R2 plus 3RT as 7. So one of the conditions that I'm getting is that R2 plus 3R3 should be equal to 7. And one more equation from the general binomial multinomial theorem term. What do I have? That R1 plus R2 plus R3. This value is always equals to 10. So whatever value of R2 and R3 and R1 I choose, it should satisfy these two conditions. So let me make the table and find out what are the values that are going to satisfy these two conditions. So R1, R2 and R3. So what are the values now that can satisfy these two conditions here? So these two conditions can be satisfied by, let's say if I have 3, 7 and 0, one of them can be this. I can have 7, 1 and 2 here. And what else can I have? I can have 5, 4 and 1. This is one more thing that can be done. So keep this thing in mind. Now that I've found only 3 cases, apart from this, I do not think there are any more cases that can be solving both these conditions. So there are 3 cases that I've gotten. So now in all these 3 cases, I'm going to get my x coefficient, sorry, my x to the power 7. If I have x to the power 7, I just need to find out the coefficient. So how would I find out my coefficient? I will simply add all these cases. The coefficient of all these cases, I'll just simply add them up and I'll get my answer. So my coefficient of x to the power 7 would simply be written down as 10 factorial upon 3 factorial, 7 factorial, 0 factorial, minus 1 to the power R2. So this would become minus 1 to the power 7, and we would have 2 to the power 0, plus I would have 10 factorial upon 7 factorial, 1 factorial, 2 factorial into minus 1 to the power 1, and I would have 2 to the power 6 plus 10 factorial upon 5 factorial, 4 factorial, 1 factorial into minus 1 to the power R2, which is 4, and I would have 2 to the power 3 here. Sorry, this is just going to be 1. Here also I'm going to have just 2 here. So this is what my coefficient of x to the power 7 is going to be. And if I solve this, all these 3 terms, what is my final answer going to come out? 960. So you can solve it by yourself and find out your answer to be coming to be 960. So this is how you are supposed to solve questions of multinomial theorem. Try to first find out the conditions that the question is asking you to, then find out cases that can satisfy the conditions that you've just found out, and those conditions or those cases would simply become your answer. The sum of all those cases would become your answer. So this is how you are supposed to solve.